So our next phase is that big orange box there. That is our runtime area. Now I say area because there's going to be a lot of things associated with this. And actually a lot of it's going to be really, really familiar. So that's the good news for all of us here. But it is a rather large portion here. So just a heads up, there's going to be multiple facets of this in this video. So the first part of the area is going to be our method area. And this really is the space and memory where our class level data, specifically the static variables, are stored. Now remember, static variables are declared with the prefix static outside of a method. They're accessible throughout the entire program. And the lifetime of a static variable is the lifetime of the entire program, the runtime of the entire program. So these are very, very specific type of variables compared to local variables or other variables that you and I've talked about when it comes to scope. They usually live, work, and die within a certain range. These are a little bit different with the method area. This is the area that we're used to. We're used to the heap area. This is where we declare our arrays, our major variables, and everything else like that. But again, notice this is a different area that's going to kind of grow and shrink and everything else like that because, again, of scope. You know, as soon as it's out of scope, Java's garbage collection will throw it out and say, hey, here's more heap memory that you can end up using. So the lifetime is the scope of the variable that's being defined. So you're going to have a lot of, well, the heap area grow and dynamically change as the program is running because of the scope that you and I programmed into it. The next part you're going to be really familiar with, and that is the stack area and the stack frame. Now, the stack area is just a broader set of, frankly, stack frames. So this is where, in memory, we're going to hold all our stacks, just our calls and value stacks, and it's going to be set up for each thread that we have running at our time. So that's why you can see multiple threads, and that would mean multiple stack frames that are going to go ahead and contain local variable arrays. They're going to have our operand stack, frame data stack, you know, where symbols are corresponding to the methods that were stored. These are all the behind the scenes information when it comes to our stack frame, which that could be a whole nother topic really on its own too, that is done within our JVM in that portion. The next portion is our PC register. This sounds familiar because it should sound familiar from either operating systems or assembly or something of that nature. But the PC, which is really program counter, not personal computer here, it registers or stores all the addresses of the currently executing programs and the stack or in the thread, really. If you have only one thread, then it's in one stack. And there's only one PC register for each of the thread. So again, notice it's not personal computer. But again, that has a small fixed space that is trying to do its job on calling everything and getting everything done. And then we have our native method stack. This is similar to a method stack area that we talked about before. But these can be written actually in different languages. And we really don't go over that in this class. This might be another topic that we get into here in a little bit. But the native methods themselves, these are methods that have been implemented, some of them in Java, but most of the time they've been written in different languages like C++ or C or something of that nature. It's able to incorporate it as well.